All right, students, hello. Sorry about the confusion at the end of the last video. On that last video right there at the end, I'm using my son's phone to record these, and his phone just about died right there at the end, and I'm sorry that I wasn't real sure if the video had saved and where I had stopped the video, so I'm sorry for all the papers mishmashing everywhere there at the end of the last video, but we'll pick right back up where we left off. And I believe we left off on number 12. Find the probabilities using a geometric distribution. Geometric distribution will be on the final exam, so let's make sure we know how to do those. A study found that the smartphones made by a certain manufacturer had a failure rate of 43%. That is our P. 4 smartphones made by this manufacturer selected at random. Find the probability that the 4th smartphone is the first one to have a failure. So I'm looking for the probability of the 4th smartphone failing. So go to my calculator. It is a geometric distribution. So you're going to go to second dister. You're going to go all the way down to the word geomet PDF. Geomet PDF. Let me write that on here. Geomet PDF, a geometric probability distribution function. On my calculator, it's letter F. If that helps, hit enter. The P is 0.43. And the X value that we're solving for is the 4th smartphone, so I'm going to make that a 4. And then hit paste, hit enter, and the answer to 4 decimal places is 0.0796. And there's your answer to number 13. Number 14, a study found that smartphones made by a second manufacturer had a failure rate of 14%. That 14% is the P. 6 smartphones made by this manufacturer selected at random. Find the probability that the 6th smartphone is the first one to have a failure. So I'm finding the probability of the 6th smartphone. So go to second dister, go down to letter F or geomet PDF. Oh, too far, there we go. My P is 0.14 and I want to find the probability of the 6th smartphone failing. Hit enter and you should get 0.065, and if you round that, it should be a 5.9 if you round that to 4 decimal places. Here we go, turn the page. And we are now to chapter 5. This was the normal. This is when we used normal CDF, and then when we went backwards we used inverse norm is when we used these. Here we go. Find the area under a shaded normal curve between. This was a betweener problem. So let's see if you remember how to do a normal curve with a betweener problem. So we did P. I have negative 1.25. I have a positive 0.125. I want between. So it is standard normal. I used the letter Z. Then we learned in chapter 5 that those are both less thans. Go to your calculator. Go to second dister. Normal CDF is number 2. The lower is negative 1.25. The upper is 1.25 in a standard. Remember, in a standard, the mean is 0 and the standard deviation is equal to 1 in standard normal. So 0, 1, hit paste. Take that to 4 decimal places and you get 0.7887. And there's your answer to number 1. Number 2, find the area under a standard normal curve to the left. So now it's to the left of 1.5, shading to the left. So your curve would look like that, to the left of 1.5. So you want the probability that Z is less than, because it's being shaded to the left, of 1.5. Now here's the question. What do we use? Go to second dister, normal CDF. What is our lower bound? This lower bound goes on and 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 forever. Forever is this way. To the left would be negative infinity, but remember we can't put negative infinity into our calculator, so we use negative 999,999 to represent negative infinity. The upper value is 1.5. It's standard normal, so the mean is 0, the standard deviation is 1. Hit paste, and you get 0.9332 should be the answer on your calculator. Number 3, find the area under standard normal curve to the right. So now we're shading to the right of negative 1.25. Again, this is going to the right. It's going on and on and on and on forever. It's going all the way up to infinity, but infinity is not in our calculator. So go to second dister. Normal CDF is number 2. The lower, the number on the left is now the negative 1.25. The upper is infinity, so it's 999,999. My mean is 0, my standard deviation is 1. Hit paste, and you should get, oh, I didn't write that, P, Z, it's going to the right, so it's greater than negative 1.25, and carry that to 4 decimal places, and you should get 0.8944. And there's the first 3. These from 1 through 3 are all standard normal. Remember, with standard normal, you have a mean of 0 and a standard deviation of 1. Now, for the rest of the page, we're just doing normal, not standard normal. So our mean and our standard deviation are going to be something other than 0 and 1. The lengths of pregnancies of humans are normally distributed with a mean of 268 and a standard deviation of 15. Find the probability of a pregnancy lasting more than 300 days. So I want greater than 300. Greater than 300 would mean you're shading to the right of 300. So that would be infinity at that end. So if you go to second dister, you go to number 2. The lower is the 300. The upper is the 999,999. But now my mean is 268 and my standard deviation is 15. Hit enter and you should get 0.0164 as your answer. Number 5, the length of pregnancies are normally distributed with a mean of 268 and a standard deviation of 15. Find the probability of pregnancy lasting less than 250. So I want X less than 250. So if I come over here and I have 250 and I want less, I'm shading to the left. If I'm shading to the left, I'm going to negative infinity. If I'm going to negative infinity, the lower number is the negative infinity. So second dister number 2, negative 999,999. The upper number is the 250. The mean is still 268. The standard deviation is still 15. Hit enter and you should get 0.1151. 2 more on this page. Lengths of pregnancy, same thing as above, are normally distributed with a mean of 268 and a standard deviation of 15. Find the probability of a pregnancy lasting between. So I want 260, 272. If it's between, we put the X in between and we always use less thans. Go to your calculator, go to second dister number 2. The lower bound is the 260. The upper bound is the 272. The mean and the standard deviation are the same. Hit enter and you should get 0.3082. And number 7, now this one's different. We'll put a star, we'll put 2 stars here. This was not like the middle section. This one's totally different. Scores for the California Peace Officer Standards and Training Test are normally distributed with a mean of 50 and a standard deviation of 10. An agency will only hire applicants with scores in the top 10%. So they're only going to hire you if your score is up here in the top 10%. What is the score? Now I'm looking for the Z. What is the Z? Up above here, I gave you all the Z's, and you found the probability of it landing in that part of the curve. Now I'm giving you the shaded part of the curve, and you got to find me the Z. This is where we use inverse norm. But the problem with inverse norm is that you can only use inverse norm when it's shaded to the left. If it's shaded to the right, it's called critical. This one is shaded to the right, so it is critical. When it is critical, you got to do 1 minus 0.10, which is 0.9. Now you're going to do inverse norm, 0.9. The mean is 50, and the standard deviation is 10. So let's see what answer that gives us. So you're going to go to inverse norm. Here we go. Let me clear. Inverse norm is under second dister number 3. The area is 0.9 because you had to do 1 minus 0.10 is 0.9. The mean is 50. The standard deviation is 10, and we're always going to the left. Hit enter, and you need a score of 62.82. I don't know, where can I squeeze that in over here? 62.82 is the score that you need to be in the top 10% of the class. All right, keep going. Let's turn the page. Actually, I'm going to stop there because my time's up, and before I need to upload the next video, so give me just a second and I'll get ready for the next video. Be patient.